Okay, in this quick video we're going to go over the signaling capacity for the Torque 3D engine. Um, it's it's really complex when you look at it at first, and then it becomes really simple when you finally understand it. So hopefully this will um, make things incredibly simple as far as your conceptual understanding of it goes. So here we got process events. This is in the main loop. Main loop goes over and over again, calls process events over and over again. This calls trigger. If you're familiar with signaling in general, generally there's trigger and there's notify. Notify is used to add a function pointer to a list, and then trigger is used to call all of those function pointers. So you can imagine calling all of those function pointers being like going into a room full of people if you're a guy trying to notify everybody, and tapping everybody on the shoulder and saying, hey, this is the thing that I'm supposed to tell you, and then going to the next guy and saying, hey, this is the thing that I'm supposed to tell you, kind of like that. um, it's really simple in the sense that if you go to one of those guys, say, in that room, and you'd be like, hey, I got something to tell you, and he's like, okay, well, cool, well, I gotta tell somebody else what you just told me. Well, he can recursively go into a different room and do the same thing. It's notification. It's basically saying, if this function pointer is called, this notification has arrived. It's really common to a whole variety of implementations of event handling, um, and it's something that is prevalent throughout all of Torque. So I'm gonna walk you through how this actually happens real quick. Um, Here we see trigger. We can actually step. Here you can see that trigger pulls the one process. The one process is just a global function pointer, or not a global function pointer, but a global object pointer that contains methods that we're going to be using. Go to subply return. That was this part of it. That function pointer that was, or that method or that object pointer that was returned, signal process.trigger will be called from that object. This is what trigger looks like. Trigger exists in the signal class. Signal class is templated. Can return either void or boolean. There are 26 total templates, 13 for void and 13 for boolean. You can see them directly below their first entries. So as you can see, we're down here in the file. Well, up here around there is where the boolean ones start. But here you can see void, void A, void AB, void ABC, so on and so forth. There are bool complements to these. It goes all the way up to M in the templating. So this is what is important here. When I said, you go into that room full of people and then you tap them each on the shoulder and you're like, hey, this is the message. Well, think of this as the room full of people, this list. So if we step, basically this right here, you don't really have to pay attention to this. This just pushes null onto this stack, or this list stack thing. And this just removes it, I think. I think that's because of the way that it iterates here. See, it goes this mlist next. I'm pretty sure it's because of that logic. It's just something that doesn't need to... It could be done differently, but isn't. This right here is at the end of the loop. This is part of the iteration logic, so this should logically be right here. But they have it down here because it doesn't really matter. This is where the message passing actually happens. This is where the function pointers are called. It goes through each of the people in the room and taps them each on the shoulder. So it goes through each of the items in the list and it calls each of the function pointers. Those are roughly identical statements. Well, I guess identical isn't the word. They're almost equivocal. So let's go ahead and continue it. It gets in there. We'll go ahead and step it. In here you can see that it gets a function pointer. So to return, that was this. This right here is overloaded. This will actually execute the function associated. This is my comment. You won't see this in your code. But step, here you can see the operator. It's the overloading of the operator. This is part of another templated class system. There are 13 of these. You can see that the difference between these is very slim. Don't quote me on how in non-different they are, or undifferent, or whatever, the certainly not indifferent. However non-differing um, they are very similar. Like here's where's the operator overloading? Here's the operator overloading. This is identical to the other one except for this one takes a pointer. So each of these different templates are used in the application for a variety of reasons, but it just makes it easy for creating signals. This right here is the entirety of the function. All it does is it gets a memory pointer to the function, and then an object pointer, and then it calls it. So this actually, that right there, those two little parentheses, that's where your code is executed. This is all just retrieval. All that I just highlighted, that's all just retrieval. So to illuminate this, let's step it. Oh, step it. So calls get closure mem pointer first, and we step it again. Get closure this, step it again. Oh, and now we should be on this. Now when I execute this, it should go into our module. Yep, it's the Telnet debugger module, and it's calling process. If I find all references on process, you'll see in Telnet debugger down here, you'll see notify, remove, and process. If I click on process, hold on, or sorry, my bad. You'll see that's where we are right there. Notify is where the function pointer is added. You can see that's the function pointer to what we were just looking at, that function we were just in. And then this is something I didn't note before. In terms of signal processing, if you want to remove something, usually there's a remove object or something similar to that. In this case, this remove is called in the destroy function. It'll destroy that function pointer. I'm sorry, it'll remove that function pointer from the list. So basically, it'll take a person out of the room. It'll basically say, okay, well, you have to tap all these people on the shoulders, but not this person anymore. Cool? Okay, hopefully this video will record fine. This is actually the 9th time I'm recording this video, which is why it's so smooth and fast. But yeah, hopefully. 175 megs, we should be good. Cross your fingers.